Hello everyone and welcome to my channel. Today we'll be discussing some applications of trigonometry. I am Helpful Tutor. For more videos of various chapters, press the subscribe button and don't forget to press the bell icon next to it. In this lesson, we'll be learning how trigonometry is used around us. Okay, previously we have discussed how it is used in astronomy to find the distance of stars and how it is used in geography to find the height of tides. So here we'll be using it to find the height and distance of various objects without actually calculating it. Let's consider that we are standing over here, that is you are standing over here, okay, and there is a very big building over here at some distance in front of you. Suppose this is the building, okay, and this is the ground. Okay, you're standing over here and this is the building. You're standing at position A and the height of the building, let's name it as BC. Okay, so now you're looking at the top of the building. The top of the building. So when you're looking at the top of the building, you'll have to raise your head and you have to raise your eye to see the top of the building, right? So this is the line of sight. This is called the line of sight. That is, you're lifting your head and you're lifting and looking at the top of the building. So that line through which you're seeing the top of the building is called the line of sight. Okay. Now, to find the horizontal line, there's one more term called horizontal line. That is when you don't lift your head, you put your head straight and your eyes in the straight form and you look to something. That line is called the horizontal line. See, so this is the normal. When you're walking, when you don't lift your head or you don't move your eyes, this is the horizontal line. This is called the horizontal. The angle formed between the line of sight and the horizontal line, that is, this angle is called the angle of elevation. Now, why is it called elevation? Because you're lifting your head to look top of it. That is something which is on top of you. Okay. So, this is called the angle of elevation. Now, there is one more condition. Okay. That is, suppose this is the building. Okay. And you are sitting in the balcony of the building. Okay. This is the balcony and you're sitting over here. Okay. And you're looking at some stone over here down on the ground. You're looking at the stone over here. So the line is called the line of sight, the line through which you're looking. Okay, and so you have to lift your head down and to see the stone, right? So when you look straight, that is from the balcony, when you look straight, that is your head straight and your eyes straight, this is the horizontal line. This is the horizontal line. Okay, so the angle formed between the horizontal line and the line of sight is called the angle of depression. Moving on to the exercise questions. Exercise 9.1, this is question number 1. It is said that a circus artist is climbing a 20-meter long rope which is tightly stretched and tied from the top of a vertical pole to the ground. Find the height of the pole if the angle made by the rope with the ground level is 30 degree. Okay, so the diagram is already given. It was already given. So the pole is AB. Okay, so according to the diagram given to us, the pole is AB and the rope is tied in the form ACC. AC is the rope tied to the ground, that is 20-meter long rope which is tightly stretched and tied from the top of a vertical. So this is the top of the vertical pole to the ground. Okay, so we are supposed to find AB now. We have to find AB is equal to how much? Angle made by the rope with the ground level is 30 degree. So now how to solve this? This is where the table which we have learned in the previous chapter, that is trigonometry chapter. So if you don't know the values of the trigonometric ratios by heart, the specific angles by heart, what you have to do is, as soon as you get your answer sheet, in the rough column, draw the table and keep it. The shortcut method for drawing the table, I have posted a video of it. The link I'll put it in the rightmost corner. Okay, so here in this triangle, so we have a right triangle ABC, right angled at B. Okay, so it's given that angle ACB is 30 degree. Okay, so in this triangle, let's say we have to find the AB. So if the hypotenuse is given 20 meter, so using which trigonometric ratio will we get AB? Okay, so is there, ka is there, 2i is there, and we have hypotenuse given. So it's either sine or cos. So we need opposite, this is the opposite of this angle. So we need opposite. So which one will we use? We will use so, that is sine. So sine 30 degree is equal to opposite AB by hypotenuse AC. Okay. Now what is sine 30 degree? Sine 30 degree is 1 by 2 is equal to AB. We don't know, we have to find it out, by AC is 20 meter. So solving it, AB is equal to 20 by 2, that is equal to 10 meter. So moving on to the second question, a tree breaks due to storm and the broken part bends so that the top of the tree touches the ground, making an angle 30 with it. Okay, the distance between the foot of the tree to the point where the top touches the ground is 8 meter. Find the height of the tree. So imagine the scenario. Okay, there was a tree. Now it has broke due to storm. Okay, so there was the broken part bends so that the top of the tree touches the ground, making an angle 30 with it. So this was the tree, okay, and it broke, and now this part, okay, it's bent and it's touching the ground now, making an angle 30 with it. Okay, so this was the tree, and now, okay, this is a big tree. Okay, so it's touching the ground now. So this is gone, so it's touching the ground now, making an angle 30 with it. Okay, so this is also tree, this is also tree. So we have to understand that. Let's consider the names as A, B, C. So AB plus BC is the tree. So this is the trick over here. AB plus BC is the tree. So it has fallen, right? It has fallen. So the whole thing is the tree. Okay. So it's making a right triangle with the ground. Okay, and it is also said that the distance between the foot of the tree, this is the foot of the tree, that is the roots and the foot of the tree, where the top touches the ground, is 8 meters. So this is 8 meter. And we also understood AB plus BC is the tree. So now solving it, let's see, we have to find AB as well as BC. AC is given to us. Okay, so first let's find AB. So we have the adjacent given, this is the adjacent. So we have to find the opposite first. So which ratio will we take? We have so, ka and 2a. Okay, the hypotenuse is not known, so sine and cos is ruled out. We have to take the ratio tan, so that we have adjacent, we have to find opposite. So let's take tan 30 degree, that is equal to opposite, that is AB by AC. So what is tan 30 degree? Tan 30 degree is 1 by root 3 is equal to, AB is not given, AC is 8. So that gives AB is equal to 8 by root 3 meters. Now we have found AB, that is AB is done, 8 by root 3 meters. Now we have to find BC. To find BC, now we can use any formula, because excluding tan, we can use sine or cos, because both opposite and the adjacent is known to us. But I'll use cos here. So cos 30 degree is equal to AC by BC, that is adjacent by hypotenuse. Assigning the values, cos 30 degree is equal to, that will give you root 3 by 2 is equal to, AC is 8 by BC. So that gives BC is equal to 16 by root 3 meters. So now we have to find the height of the tree. So the height of the tree is equal to AB plus BC. So that is equal to 8 by root 3 plus 16 by root 3. So that is equal to 24 by root 3. Now rationalizing it, we will have multiplying root 3, so that gives 24 root 3 by 3, so that gives 8 root 3 meters. Moving on to question 3 from exercise 9.1. I just shortened the question a little bit, just added the important points only. So the whole question is, a contractor plans to install two slides for the children to play in a park. For the children below the age of 5 years, she prefers to have a slide whose top is a height of 1.5 meter and is inclined at an angle of 30 degree to the ground, whereas for elder children, she wants to have a steep slide at a height of 3 meter and is inclined at an angle of 60 degree to the ground. What should be the length of the slides each case? So there are two conditions, two slides. So we'll draw two diagrams in keep. So two slides for the children to play in a park, one below 5 years. So below the 5 years it will be shorter height and shorter inclination also. So 1.5 meter and inclining at an angle of 30 degree to the ground. So this is at a height of 1.5 meter. Okay, and the one which we slide on is the length which we have to find. So this is the ground. Okay, and inclining to the angle of 30 degree to the ground. So this is 30 degree. We'll name this slide as A, B, C. Okay, the other one for the elder children is at a bigger height, that is height of 3 meter, inclining at an angle of 60 degree to the ground. We'll name this as D, E, F. Now we can solve this. So in this triangle ABC, we have sine is given, the angle is given as 30 degree and the height, that is opposite is given to us. Opposite is given as 1.5 meter, that is it is given. Now we have to find BC, that is the hypotenuse. So which ratio will we use to find the hypotenuse when opposite is given? So so opposite and hypotenuse, so it's sine. So we'll use sine 30 degree is equal to opposite, that is AB by BC. Now we know sine 30 degree is equal to 1 by 2, that is equal to AB is 1.5 by BC. So that gives BC is equal to 3 meters. So BC is equal to 3 meters. Now moving on to this triangle here, we have again sine is given 60 degree and we have the opposite, and again we have to find the hypotenuse. Okay, so we use the same sine over here. So sine 60 degree is equal to opposite, that is DE by EF. So sine 60 degree is equal to root 3 by 2 is equal to DE is 3 by EF. So that gives 3 to the 6 by root 3 meters. Now we have to rationalize it. So that is equal to multiplying both top and bottom by root 3. So that is equal to 6 root 3 by 3 meters. Again we can simplify it further, that is equal to 2 root 3 meters. Now moving on to question number 4. The angle of elevation of the top of a tower from a point on the ground which is 30 meter away from the foot of the tower is 30 degree. Find the height of the tower. So read the question again. The angle of elevation of the top of a tower to the top of the tower from a point on the ground which is 30 meter away from the foot of the tower is 30 degree. Find the height of the tower. So let's imagine this is the tower I'm very bad in drawing straight lines. Okay, so this is the tower AB. Okay, so now it is said the angle of elevation of the top of the tower, that is top of the tower, is A, from a point on the ground which is 30 meter away from the foot of the tower. That is, this is the foot of the tower, this is the top of the tower, 30 meter away from the foot of the tower, that is this one. So 30 meter away from the foot of the tower, that is this point. Let's consider this point as C, is 30 degree. Join it. So this is 30 degree. This is right angle. Now we have to find the height of the tower. So we have to find AB. Okay, irrespective of angle C, that is irrespective of 30 degree, this is adjacent. Okay, this is adjacent. So we know adjacent and we have to find opposite, right? So this is opposite of 30 degrees. So we have to find opposite. So which is the ratio we'll be using? Is it so, ka, or tua? We have adjacent, we have to find opposite. So we'll be using tan. Tan is opposite by adjacent. So tan 30 degree is equal to opposite is AB by BC. So we have tan 30 degrees equal to 1 by root 3. AB by BC is 30. So that gives AB is equal to 30 by root 3. So multiply it with root 3 to rationalize it. So that is equal to 30 root 3 by 3. So that gives 3 and 10. So 10 root 3 meters. Moving on to the next question, question 5. A kite is flying at a height of 60 meter above the ground. The string attached to the kite is temporarily tied to a point on the ground. The inclination of the string with the ground is 60 degree. Find the length of the string assuming that there is no slack. Okay, now read the question again. It is said that a kite is flying at a height of 60 meter above the ground. Okay, so let's consider a kite flying 60 meter above the ground. So that is, it is 60 meter above the ground. Okay, so this is the ground, 60 meter above the ground. The string attached to the kite, so we always hold a string, right? So that is temporarily tied to a point on the ground. So let's consider this is the point. It is tied to the point on ground. The inclination of the string with the ground is 60 degree. So this inclination is 60 degree. As you read the sentences, as you read each sentence of the question, the information from it, mark it then and there itself, so that you don't get confused. Each line, read it, understand it, and then draw it accordingly. Okay. If you don't understand the question, read it twice so that you understand it. Now, the inclination of the string with the ground is 60 degree. Find the length of the string assuming that there is no slack in the string. So, it means that there is no slack in the string. It is straight, okay? There is no slack. So, this is the triangle we got over here. So, we'll name it as ABC, okay? And respective of angle A, that is opposite is given, okay? Opposite is given. We have to find the length of the string, that is hypotenuse is what we have to find, hypotenuse. Okay, so when opposite is given, we have to find hypotenuse. So which ratio will we use? So ka to a, so opposite is given, so we have to find hypotenuse. So sine we'll use. So sine 60 degree is equal to opposite, that is BC by AB. Okay, so what is sine 60 degree? Sine 60 degree is root 3 by 2. So BC is 60 by AB. So that gives AB is equal to 60 times 2 is 120 by root 3. Again, rationalizing it, root 3, that is equal to 120 root 3 by 3. So that gives 3 4s are 12, so 40 root 3 meters. I hope so far it is clear for you all. We'll continue with the next questions in the coming videos. If you liked my video, please press the like button, and for more videos, press the subscribe button and the bell icon next to it. If you have any comments or suggestions, or you want me to do any particular questions or portion, please comment in the comment section, or you can even email me at helpfultutor19@gmail.com. I'll post it in the description box below. Thanks for watching my videos. We'll see you in the next video. Bye.